Okay, for this video, I will show you some of the features you can find under move components. So for this feature, usually we use to analyze your assembly models. Okay, here is standard. You have standard drag, collision detections, and physical dynamics. So how are we going to use this? Okay, let's say I design a rack and pinions. So I need to know whether the bottom rack here is able to move the gear or not. So if I just move it like normal, you will see what happened on the T here. It just go overlap. But how I going to know whether the model that the part that I design, it can work or not, is function or not? Okay, the first thing I will show you what is collision detections. So for collision detection here, if your models is colliding with each others, for example, if I move, okay, it automatically detect the dynamic, physical dynamics. Okay, maybe I will show you this one. Physical dynamic, if you pick physical dynamics for the move components, okay, you will find out when the component is now is touching, you see. When the part is hitting, it will highlight. At this zone here is colliding. Then it will let you, it will sound like tang, tang, tang. You see. For the collision detections, when I move back, this area here is colliding. Then it will show you, oh, this part is actually colliding. Okay, then let's show. Okay. Now you see, no more colliding. So if your part is starting with colliding, when you run the physical dynamic condition, it will show you cannot run any physical dynamic analysis on this because the starting point is colliding. So the first thing you can use collision detections. You can until okay. Stage, okay, let me move again. The initial stage is not colliding. Then I will start with the physical dynamic. Okay, you can see from here the physical dynamic. If I move this part here, it will write real part. It will move. It won't go overlap, you see. This is how we're going to test the functionality of your assembly model, you see. Okay, I can show you the other examples here. Okay, if you design a gear, you are not really sure your gear can function or not. Before you create animations, maybe you can test your design with this physical dynamic analysis and the collision detections. Okay, so for collision detection, first thing I will make sure, you see, when it's colliding, it will sound like ting, ting, ting like this. And then it will highlight the face is colliding. See? Okay, make sure, okay, the two part here is not under the colliding conditions. Then I will use physical dynamics analysis. I will test, you see. When I move the gear can move like real. So this is the use of the physical dynamics analysis. Okay, for these examples, we have a gripper here. Okay, the gripper here, now the gripper is without any limit made. So if without any limit made, you will see here when I move the handle, this part here, it will like go overlap. If I make it open, this part here also it will go overlap. You will see from this part here actually is overlap. Okay, when I want to set a limit made, how am I going to know what is the maximums the gripper can open? But I know that the minimum is 0 distance. And for the limit mate, how are you going to set the limit mate? Okay, actually I'm going to set the limit mate between the this part here and the handle here. So the first thing we need to know what is the limit distance between here and here. So let's say I put a smart dimensions. Let's say I put a smart dimension, so it will show a reading. Okay, now it will show the reading. Okay, from here, you will see if I close, then it will show a minimum distance. But how am I going to know, is it fully closed or is over closed? And when it open, how are you going to know this distance? It will show the gripper is completely closed, it's completely open, or is over open, means this part here is colliding. So from here, what we can do, we can use the analysis. We call it a collision detection. Okay, this collision detection, when you move the gripper, you will find out. You see, we can pick the option. We call it a collision at stop at collision. Means when I fully open the gripper, you see, once the part is colliding, then it will stop. Okay, this means in the real world, this gripper, the distance between the piston and the body here, it only allowed to open maximum 3.24 cm. Okay, this unit is cm. Yeah? And when I close this, completely close, the distance is 0.5. 0.5. You see, because when I use a collision detection, it will show when I completely close here, and I will get the distance 0.5. So remember, maximum 3.25, a minimum is 0.5. So when we set the limit angle mate, okay, when we pick the limit advanced mate, it just remembers the value 3.25 and 0.5 that we get from the analysis just now. Okay, so this is a limit distance mate, so your maximum distance will be 3.25, and just now when fully close the gripper, the distance will be 0.5. Okay, then we can pick the reference. I will pick here. Okay, then I will pick here. Then confirm. Okay. Okay, now we can try. I move this handle. You see, when it completely closed, the distance here, it will be 0.5. And when I opens, when it fully opens, the distance will be 3.25. So we don't need this smart dimension anymore. Then you can see your gripper now is look like real. It won't go overlap because we have set a limit distance mate.